In this video, we'll talk about data analysis. So we learned about how to calculate the average, the median, the mode, and the standard deviation. So that's mainly how we characterize the data numerically. And we could do that also with the graph graphically. So just put the data in a graph and see how it look like. So it can give us, if we are visual, it will give you a better idea. So let's say if we are measuring diameter of an object or a bottle here using two different tools, like a scale and a caliper there. And you can see the scale can measure to the 0.0 to the 0.1, so that's in tenth. The caliper can measure in thousandths, so that will be higher resolution for the caliper than the scale, which also means that it should give you more accurate results, and when we repeat the results. So if you look at the graph, actually it will give you a better idea than looking at the data here. So the caliper is the red marks, the scale is the blue marks. So you can see the caliper is almost, or they are all repeatable or high resolution. And assuming that the green line is the correct diameter for the bottle, so you can see they are within closed region. None of them fall away from the expected value. Compared to the blue ones, you can see some of them are far away. So that's so that if we talk about the accuracy, then the caliper will be more accurate than the scale. And also, if we talk about repeatability, because you can see every time we repeat, they almost you get almost the same, closed numbers, so that's more repeatable, which means more precise results than what we get from the scale. Okay, and again, we already learned how to do the average. So again, mainly you have to learn the function. It's called average, and you have to highlight the values there. So maybe you just highlight these, and that will give you the average for them. So from B14 all the way to semicolons to B21. And then the median, the function for that is median. So this is just median and the same range, B14 to B22. And the standard deviation is STDV. So that's the function dot S, and you put the same range. And we apply the same thing to both the caliper too. So if you apply that, so you can see the same functions exist, but different data range. So that's from C14 to C21. And the median is the same function, median from C14 to C22. And the standard deviation is STDEV dot S, and the range from C14 to semicolons to C21. Now, how do we make the graph? Again, you highlight the three columns without the average and median, and then you go to insert. So let's just do that. So again, to highlight, you click in the right top corner, and you keep clicking, and you just drag to the bottom right corner. So this is mainly what I need. I just click there, and just you can see you can highlight, and keep clicking on the mouse, and then just drag and until you reach to the last cell that you want to select, and then you release the mouse. You come to insert, and you go to charts, and for this one we need the scattered, so that's the one that we want. And you can see we have different options, so just pick the one that you want. So this is, we already have it, so that's if I do it. So you can see now I have another graph if I want to do that. And then you could come change like what I did here. You just come and change the mark. So you click in one of the marks, so that all of them will be highlighted. Then while they are highlighted, you right click and then format data series, and then you click on the first icon here. Then you come to the mark, and then you change the mark options, and then you come to build in, and you can change it. You can pick other shapes like square, diamond, triangle, X. So let me pick a triangle here. And also you could change the size. Maybe 5 is too big. You can go 3, or you could go larger too if you want. And then you could also change the color. So how about we go with the green, and you accept that. I think I changed the green to the, so that's how you do it. And then you come here to the side, you add the title, you add also access titles, and if you need to add any ligands, if you have multiple, since we have two data series, that's also recommended. And just keep making improvement to the results. Since we already have one, I'm not going to, just going to delete that and just keep using this one. And yeah, the standard deviation is just show you how is the value cluster around the mean. So you can see the standard deviation is smaller using the caliber than using the scale, which makes sense here because all of the results we got from the caliber are clustered to the green line compared to the one we got from the scale. You can see they are spread from 1 all the way to 1.2, and so that's more larger range, which is also higher standard deviation. You have to learn how to do it numerically, and also it's important to look at the graph because it can give you a better way of looking at that. It's just a quicker way of seeing the trends. Okay, let's look at another example here for data analysis. So let's say for one experiment we measured, or we collected 20 data points, so from 1 to 20, and you can see these are the results. And this is just looking at the data, but I think as again, it's easier to see the data in the chart. So these are the blue marks or dots are the data points from 1 to 20. And if you notice that one of them, just all of them can fall within relatively close to each other, except one of them is like the 45.2 is away from them. So that could be an error or something. We call these outliers. So this is kind of important to understand if this is something happened by error or not, so to better understand the results. And it has significant impact. If you see here, and we'll talk about how it impact the mean for the data. So I put here is the mean for the data is the red line, and the green line is the median. And you can see the mean is higher than the median, mainly because that outlier is increasing them. Because to calculate the mean, we add the results or the measurements and we divide by their number. And let's say if one of them is almost double the other ones, then it will affect the results. This is why we have a higher mean than the median in this case. So this is like what we did before. Like to find the mean, I just use the function average, equal average, and you just highlight the data that you have. In our case, B4 to B23. And to find the median, you do the same thing. You just use the median function. So this is median, parentheses, then B4 to B23. And to find the standard deviation, you do the same thing, stdev.s, and then you put the B4 to the range of the data by highlighting it. Why sometimes it's a good idea to measure both mean and median, so that median is not affected by, because remember to find the median, mainly we arrange the results from the smallest to the highest, and if they are odd number of data, we pick the one in the middle, and if they are even number of data, we pick the two in the middle and we divide by 2. So that's not going the outlier will not affect the median, because it will just be in the top. I mean, not like it will be affected. The mean will be affected, and this is how we do that. And again, to do the graph again, just you highlight the results, both trial 1 and trial 2, and then you insert and you come to the chart, and you pick the one that you want. And then to add the mean and median, you have to you can make another column here. You just call it mean and just put the same value here. If this is how standard deviation is calculated. So this is the equation for the standard deviation, and mainly we have the data points, and we find the average for them. We could do that manually, just adding them, divide by their number, or we just use the average function. So that would be easier, just average and just highlight all the data points. So that's your average. And then we subtract, we make a column here, X, which is each data point minus the standard deviation. So this is kind of the way to do it. And make sure to when you do this, we make sure to pay attention to the relative reference compared to absolute referencing here. So when you do the average, you should use the $sign stands for, so that it does not change. So if we go from one cell to the other, you can see that B54 is the same, so that's absolute reference. But if you look for the other one, the X is changing, so going every time I move to the next one, it keeps changing. So the first one, like X is relative, we make it relative reference, and we make the mean absolute reference. If you don't do that, you get wrong answer. So let's say if we just start over, if we say X, so just equal X minus, I click on the average here, and I click there, and if I drag, that's going to give you a wrong answer. So that's not correct, because we did not forget, or we did not change the mean to absolute reference. So you have just changed that to absolute reference, or at least mixed reference, by making the raw number fixed. And now by doing it, and then we can drag again, so that should fix the results. So then we have the variance, which is we take each we square the deviation, and we divide by the number of values minus ones, which is in this case 20 minus 1. So each of them, we square the difference, divide by 1, and then we find the summation for the variance, and then you find the square root of that. This will give you the standard deviation, which is 6.428. And again, this is how we can do it manually, but we could just, instead of doing that lengthy way, we can just do that with the function. So just stdv. So that's mainly the way we do it, but just for you to compare. So we got the same results using the function, or using the definition of the standard deviation, and just by doing the calculations ourselves. So you have to know how to do it, because sometimes you will be asked to calculate the standard deviation, so you understand how to do this. So that's X is the data points, then X minus the mean, which is the deviation, then deviation square over n minus 1, that's the variance, and then find the square root of add all the variance, that then you find the square root of that. That will give you the standard deviation. Okay, thank you.